Forget glossy lunar city renders. Reality is harsh. 3D printers, regolith, and energy make moon colonization a logistical and financial nightmare. Every step adds cost, risk, and complexity. Could a lunar home cost tens of millions per square meter? Payload, energy, and maintenance make costs explode. The dream isn't cheap. NASA gave Icon $57 million to develop a lunar 3D printer. But transport, power, and maintenance challenges mean this printer alone won't build a colony. Living on the moon is a dream, but physics and economics hit hard. Wall thickness, energy, and materials multiply costs quickly. Landing a 10-20-ton printer costs $100K, $300K per kilogram. Payload alone is extremely expensive, even before building a habitat. Starship can deliver only 150 tons to the moon. One habitat module may consume almost the entire payload, hundreds of millions for logistics alone. Airlocks, tools, and spares must ship from Earth. Every kilogram adds massive cost, and a single failure risks the project. Each Starship launch costs over $100 million. Heavy payloads need lunar refueling, making logistics complex and extremely expensive. Processing lunar regolith to solid walls requires heating to 1,000 degrees Celsius. Each kg needs 7,100 LJ. Energy requirements scale into megawatt hours quickly. 100-200 meter square pressurized habitat requires hundreds of tons of regolith processed. Energy demand is extremely high, beyond solar panels during long lunar nights. Lunar nights last 14 Earth days. Colonies need nuclear microreactors or huge batteries shipped from Earth, adding cost and complexity. Energy alone can bankrupt an early colony. Every kg of regolith, every module, and every robot requires massive power. 1 atmosphere inside, vacuum outside. Walls must be 2-3 meters thick for structural integrity. Lunar surface swings from -173 degrees to +127 degrees. Thermal expansion could crack walls if not designed carefully. To block cosmic rays, 2 to 5 meters of regolith shielding is needed. Mass and transport costs rise fast. Airlocks, windows, and seals must come from Earth, increasing weight and cost significantly. Lunar dust is abrasive and electrostatically charged. Robotic arms and printers wear out quickly, making maintenance difficult and costly. Dust alone can shut down operations for weeks. Printers fail often. Spare parts ratio may reach 5:1, meaning multiple backups per component. Shipping these from Earth adds billions to project costs over time. Operating robots from Earth faces signal delays. Even small tasks take hours due to latency, making teleoperation inefficient and increasing costs dramatically. Maintenance, replacements, and unexpected failures blow up budgets. Even a single minor malfunction can cost millions and delay the entire lunar project. Initial printer setup costs $501, including transport. Just getting machines to the moon consumes massive budget before construction even starts. Nuclear reactors or batteries add 500 M plus more. Power systems alone are huge cost drivers for any lunar colony. A 100-meter squared pressurized habitat costs $10.50 million per square meter. Transporting materials dominates the budget. 3D printing doesn't reduce costs enough yet. Moon colonies are hype-heavy. A self-sustaining lunar economy is decades away. Today's dream is expensive, risky, and far from reality.